In this tutorial you will learn how to apply vector-based approach to extract specific ISO curves from fluid forms using Grasshopper. In the part 2 of this video you will learn how to fill the gaps in between sub-Ds using advanced methods, and as a final step we'll join all surfaces into a single one and create slabs. Without further ado, let's get started. Hi guys, Lazar here, and the base geometry in this tutorial is created in sub-D and it is inspired by the project OCULIS 10 Towers for Thessaloniki, designed by OF Studio and Degree 0 Architects. And in this video we'll focus on these 4 towers that are connected by 3 bridges. So first you need to have sub-D geometry. In this particular case it's contained by 10 different sub-Ds. The main reason of dividing them into multiple shapes is because the ISO curves that we need should have at least one part which is vertical. Once this is done, we can start with the Grasshopper magic. If you're interested in how to get sub-D shape like this one, please stay until the end of the video. Alright, before we get started, please make sure that you set absolute tolerance in Rhino options to 0.001. So you can type options and it will pop up the Rhino options window, and in the units here in the absolute tolerance you need to set 0.001 units. Click OK. Once this part is done, now we can import sub-D geometry in Grasshopper. Please make sure that we have 10 different sub-D objects. So this first one, so 1, 2, 3, 4, 5, 6, and we have 4 parts on the bottom. So I will type sub-D container and I'm going to reference set multiple sub-Ds, and if I connect with the panel we have 10 reference sub-D in Grasshopper. Alright, I'm going to hide this for now, and in the next step I will connect to BWrap because I want to have faces from each sub-D. And you can see that we convert each sub-D into poly surfaces, and after that I'm going to extract ISO curves for each face of the BWrap. So we need to extract each face first with deconstruct BWrap. So type deconstruct BWrap, and here we get I think 10 different branches. Inside each branch we have a list of faces for each sub-D, and in the next step I'm going to extract ISO curves. So I will connect face with the S input of the ISO curve. I will graft and I'm going to reparameterize. Once this is parameterized, in the UV input we need to place coordinates from 0 to 1 for the X and for the Y. So I will use component construct point, and we're going to create several points. So in order to create several points I will first construct domain from 0 to 1, place in the range, and here we can get equally distributed values from 0 to 1, and in the end we should place how many equally distributed values we'll get, or on how many divisions we want to divide domain from 0 to 1. Okay, and basically what does it mean if we connect with the construct point? If we have a surface like this, and this is U direction and this is V direction from 0 to 1, and this is also from 0 to 1, and we get values, or we construct points 0, 0, which is this point. Maybe I should take another color. Then we have 0.2, 0.2, 0.4, 0.6, 0.6 for X and Y, 0.8 and 1. So at these 6 points we'll extract lines or ISO curves along V direction, and we'll extract ISO curves along V direction, and we'll get these lines. So based on these 6 points. But if I want to remove this line from the list, I will remove the last number from the list. Why I want to remove this line? Because we get a bunch of these faces, and in these positions we'll get overlapped lines, because for the next surface we'll also get this line, this, and these guys. So if we exclude this line from the list, we will avoid overlapping. So for the third face we'll get these 5 lines. So this is what I'm going to do. I will use cal index, and in the I input I will place -1 because I want to remove the last item from the list. And here we get everything except number 1. But there is one more step. Instead of 0, I want to place a number which is slightly larger than 0. So I will use component replace items, and the item that we are going to replace is positioned at the index 0, and I want to replace with the number which is slightly larger, let's say 0.0005. And the list right now looks like this. Once you replace 0 with 0.0005, I will explain later why this step is very important, but for now just keep that in mind. I will go on with the script. So once we get these 5 values, I will connect them with x and y input of the construct point. Once you construct points, I will check at data tree, and I want to get only branch 0 instead of a 4-layered branch. So if simplify doesn't work, I'm going to flatten this, and we get only 1-layer branch. Okay, and I'm going to connect these points in the UV input of the ISO curves. Once we get ISO curves along U and along V direction, I want to place them into their corresponding sub D shape. So here we have 10 sub Ds. These UV ISO curves I want to place into 10 different branches. So I'm going to first merge them, and here let's take a look how the data tree looks like. I'm going to simplify first, and we get a 3-layered branch. So but we need to get only 10 branches. On the left side we have values from 0 to 9, which means we need to trim this data tree with the value of 2. So which means we're going to trim all these values, and we're going to keep only values from 0 to 9. If we take a look, we get 10 branches. Inside each branch we get ISO curves related to their sub D, and we can visualize some of the branches. Here I will type any values from 0 to 9, and you can see that in the branch 0 we have ISO curves related to this sub D. In the branch 1 we have another set of ISO curves, in the branch 2, and the same logic for each branch from 0 to 9. In the next step I'm going to join them, and once we join them I will extract, maybe I should turn off all of this and these guys as well. Once you join the curves placed in the same branch, I'm going to divide them using component divide curve, and I will, let's say, create slider from 0 to 100, and arbitrarily I will place number 60, place in the N. And what is idea? I want to extract points placed in the index 0 and 1, and also in index -1 and -2, which means first two and last 2 points from the list. Then I'm going to create the vector based on these 2 points and check if that vector is similar to z vector. So let me demonstrate. I'm going to type here from -2 to 1. So here I will extract item 0 and item 1. So basically first 2 points from the list, and I'm going to construct a vector 2 point. Also, I want to construct the vector based on the last 2 items from the list. Why I'm doing this? I will turn off just for a moment. I want to keep only those lines that have segment, either first segment or last segment, which is vertical. If that segment is vertical, or if it's similar to z vector, I will keep that ISO curve. Otherwise, I will remove it from the list. So, which means if we have a line, let's say this ISO curve, and I'm going to extract first 2 division points, we create this vector and we extract these 2 points, we create another vector, and we check either one of these 2 vectors are similar to z vector. If it's similar, we're going to keep that ISO curve. Or if we have, let's say, this ISO curve, we extract this vector, let's say, and so first 2 points, and let's say these 2 points or last 2 points from the list. None of these 2 vectors are similar to z vector, and that means we're going to remove that ISO curve from the list. So that's what I'm trying to achieve with these 2 components, vector 2 point. And now let's take a look at data structure. I'm going to simplify this guy, and I'm going to simplify the other one. You can see that once again we have more than 10 branches, which means I will use trim tree in order to get 10 branches, and here as well. And now I will use component dot product. These components, it's great if you want to find similarity between 2 vectors, and this is what we need. In the A input, I will place the vector that we get based on the first 2 points that we get from the division curve, and here as well. Don't forget to unitize the vector in order to get values from 0 to 1. If the value is equal to 1, it means that vector is the same as that coordinate, or if that vector is almost 1, it means that vector is very similar to unit z. So that's why I'm going to use absolute, because we get either -1 or -0.999, which means that vector it's the same as z, but it has another direction. So that's why we'll use absolute, and here as well. And now we are going to check whether one of these 2 values placed in the same index is similar to 1. If it's similar, we are going to keep that line. So for that, I'm going to use merge. Don't forget to graft, because I want to place in the same branch of values from the same index. Once we get these values, I forgot here to unitize, and once we get these values, I will sort them, because I want to keep a larger value only. So I will sort them, reverse. Once we reverse, we'll set the list into decreased order, and I will extract item with the index 0. All right, now we are going to check whether some of these values are similar to 1, and in the T input or threshold we should place values from 0 to 100. Okay, and once again I will trim 3 because I want to get 10 branches, and number of items should be equal to number of items that we have here. Let's compare. Okay, that's correct. And now we can use component cull pattern. So these ISO curves that we get, we're going to cull with the pattern from similarity. Okay, and you can see that we have some of the lines that we don't need. So I don't want to have these lines in the list, and we can remove them based on the threshold input. So if I decrease this slider, we are going to remove unnecessary ISO curves. I'm going to turn off them, and let's see what we have. So this is the method how we can keep only those ISO curves that we need. So it's based on the vectors, and if I zoom in here, you can see that here I have the line which I don't need. So I don't need these lines. And also, let me zoom in here. Also, this line I don't need as well. So to remove these segments of the curves, I will find the discontinuity, and I will check how many items we have. So I will use list length, and if the list length is equal to 2, we are going to keep those curves. Otherwise, another curves we need to modify. Actually, we need to explode them. So let's use component equality. And if the list length is equal to 2, and now once we get the pattern, I will place in the dispatch. But don't forget to check data tree, because once again we have more branches that we need. So I'm going to simplify, and I'm going to trim in order to get 10 branches as we have in the cull pattern. I'm going to simplify this one as well, and the pattern I will place in the dispatch. L will be linked with the cull pattern. So in the A we have curves that don't have horizontal lines. In the B we have those lines. So these horizontal lines we need to remove from the list. And how we can do this, I'm going to find once again discontinuity, and I will break those curves at these positions. So for example, if we have, we'll turn off this. So if the discontinuity is positioned here, I'm going to break this curve into 2 parts, and in the shatter output we should have 2 items. Let's have a look. That's right, we have 2 items for each curve. And once again I'm going to divide curve. Number of divisions, it's not important because I want to extract first 2 points from the list. So I'm going to press here plus, and here we have index 0 and index 1. Based on these 2 points, I will create a vector, let's zoom in here once again. Here we have these 2 points, and here we have these 2 points. We're going to create vector. This is first vector and second vector. If the z coordinate of the vector is similar to 0, we're going to remove that segment, which in our case is this one. So it means we're going to deconstruct the vector. I'm going to take a look at the values that we get once we deconstruct the vector. So I will take a look at the z component. I will simplify and I will trim 3. So and also don't forget to round these numbers. So I will round their nearest integer. And if the value of the z component is equal to 0, I'm going to remove those guys. So I will use output inequality. So I will use call pattern inequality output, place here. So we keep only those segment lines that are not horizontal. And let's take a look at data 3 once again, and I will remove the branches with 0 items. So in the E I will place invert, and now we can merge these guys. So this set of ISO curves and the other set of ISO curves, flatten and join curves. Alright, so this is the final output of the lines, and based on these lines that we get, we can create pipes. So first I will set the radius. Let's set radius 0.15, place in the R input, and the base curve will be the final output that we get. Alright, and if you want to get a less number of ISO curves, we can decrease the slider to, let's say, number 3. For all of you who would like to go a step further, we created an extended tutorial in which you will learn how to create sub-D shape that we used in this video. While I was modeling the final geometry, I used some tips and tricks that might be helpful for improving your modeling skills. This you can watch on our Patreon page and support our work at the same time. With that, you will also get access to all our extended tutorials and project files. In the part 2 of this tutorial, we are going to create surfaces that fill the gap between sub-Ds, and all these surfaces we are going to join with the polysurfaces generated from sub-D, creating a single B-rep. In the last step, that B-rep will be contoured, and based on the contours, we'll create slabs. Stay tuned and make sure you have notification bell turned on so you don't miss anything. Take care.